Okay, topic today is reflection of sound. Here the definition starts. When a sound is incident on the surface of a medium, we can say when a sound hits the surface of a medium, it bounces back into the same medium or into the first medium. This phenomenon is called reflection of sound. So, this is the definition of reflection of sound. Now, we are going to add some information about echo. It is also known as echo. Here, in a bracket on your book, you will write down if the reflection of sound is produced by a surface at least 17 meters away from the point of source of the sound, then the reflection of sound is called echo, because then we hear the second same kind of sound, and this acts as echo. And if the distance is less than 17 meter, then we cannot hear echo, or we cannot hear another same sound, because the same first sound and the second reflection of sound both are merged, and so we cannot hear a separate sound called echo. Okay, now here next question arises that why echo is produced. So to answer it, here in this paragraph, the sensation of sound persists in our brain for about 0.1 second. It means whatever the sound we hear remains in our brain for about 0.1 second, or we can say 1/10 of a second. So to hear a clear echo, the time interval between our sound and the reflected sound must be at least 0.1 second. Okay, here this is the least time which is a must to hear a clear echo. Now we will calculate the distance for the echo. So if we consider speed of sound to be 340 meter per second at normal temperature in air, and usually normal temperature is 25 degree centigrade. Now here we will hear echo after 0.1 second. Time to hear the echo is 0.1 second. So we can make a data like this. Here you see time is given 0.1 second. Velocity at normal temperature is taken to be 340 meter per second. Then the distance is to be calculated. And how you calculate this distance? We use the formula S is equal to V into T. Here 340 multiplied by 0.1, and we got 34 meter. So distance, here the sound is produced, it is going away, hitting some surface and then returning back. Here you are present, you are hearing it. So the total distance is, this is the total distance from starting point to the hitting point and then bouncing back up to U. So here D plus D, it is 2D. So it means 2D is equal to 34 meter. So D is equal to 34 by 2 meter, means half of 34 meter. So the distance of the obstacle or the barrier must be half of 34 meter, and that is equal to 17 meter. Here in your book it is described in wording. Here you can see the total distance covered by sound from point of generation to the reflecting surface and then bouncing back should be at least S is equal to V into T, and it came 34 meter. Thus, for hearing distinct echoes, the minimum distance of the obstacle from the source of sound must be half of this distance, that is 17 meter. Thus it is proved, to hear a clear echo, time must be 0.1 second and the least distance must be 17 meter. There can be different hurdles at different distances more than 17 meter. So what will happen? We will hear many echoes. Echoes may be heard more than once due to successive or multiple reflections from multiple hurdles, which must be equal to 17 meter or greater than 17 meter.